What caused this explosion? Was it fission or fusion?
Meet Atom the atom. Atom is made up of protons, which are positively charged, neutrons, which have no charge, and electrons, which are negatively charged. Fission is the process of splitting atoms. In this process, a free neutron disrupts the balance in an atom, splitting its nucleus in two and releasing a large amount of energy. The force holding the nuclei of atoms together, keeping the positively charged protons and neutrally charged neutrons from separating, is the strong nuclear force. The force pulling them apart is the electromagnetic force. In the nucleus, the nuclear force is the stronger force. However, when a free neutron disrupts the balance of an unstable nucleus, such as that of uranium-235, the nucleus becomes deformed, and the electromagnetic force overcomes the nuclear force. This is critical deformation. Let us look at uranium as an example. A free neutron moving at high speed hits the uranium atom, causing it to deform. At this point, the atom reaches critical deformation. The electromagnetic force overcomes the nuclear force, pulling the atom apart. The atom splits, giving off energy and releasing neutrons.
Neutrons, given off by an atom splitting, can then cause the fission of other atoms. This results in a chain reaction. Because each fission reaction can cause a fission of three other atoms, and each of these reactions releases energy, a nuclear chain reaction can release an enormous amount of energy. This fact is taken advantage of in A-bombs and nuclear power plants. Nuclear power plants make power by using controlled fission reactions in the reactor core to heat water, turning it to steam, which in turn runs a turbine. This turbine is connected to a generator which produces power. This brings us to fusion. Fusion is a process of combining atoms.
Fusion is the process that occurs in the sun, and it produces more energy than fission. In a fusion reaction, two atoms come together at high speeds, forming a single, larger atom. In most substances, the positive charge of nuclei prevents them from making contact with one another. However, if the atoms are moving at sufficiently high speeds, they are able to overcome the electromagnetic force and collide. When this happens, the nuclear force prevails and the atoms fuse. Let us take hydrogen as an example. Two hydrogen atoms move at very high velocities, overcoming the electromagnetic force repelling them. The atoms collide, and the two atoms are pulled together by their strong nuclear force. This causes them to fuse, becoming a single helium atom. When this happens, a large amount of energy is given off. This is why the sun is so hot, at 30 million degrees. Every second, the sun transforms 657 million tons of hydrogen into 653 million tons of helium. The remaining 4 million tons is converted to energy according to E equals mc squared, which states that energy is equivalent to mass. It is for the same reason that a hydrogen bomb is so powerful. The same process is occurring, but on a much smaller scale. A more constructive use of fusion would be the creation of a fusion reactor. Fusion is capable of creating extremely large amounts of energy with very small amounts of fuel. There is no pollution involved, radioactive or otherwise. The byproduct is clean, non-radioactive helium. The problem is that extremely high temperatures are required if the atoms are to attain sufficient velocity to overcome their electromagnetic repulsion and fuse. At such high temperatures, all materials vaporize. The solution is to use a magnetic field to contain the reaction. Fusion reactors, such as this one, in which deuterium is fused using lasers, do exist. However, they use more energy than they produce. If we were able to create one that had a net gain, we would be able to produce almost limitless energy.
This is an example of the potential behind the understanding of fission and fusion. Fission and fusion are the underlying concepts behind the atomic bombs, nuclear power plants, and the stars, like our sun. They are two of the most essential processes, the splitting and combining of atoms. Thank you for watching, and tune in next time when Greater Than Seaman will explain how to go faster than the speed of light. See you then!